Alright, welcome all geometry students. We have one last section before we're all done and ready for the FSA. You've made it to the end. So this is review for section 14 for the district assessment. So we'll go ahead and start. Consider the table below. Which state has the largest population density? You want to make sure that it's asking if it's the largest or the smallest population density. So the way we find population density is we divide population by land area. So population land area, population land area, population land area, and then we figure out what they all are. So I'll just show you a couple. So we'll take 39,250,017. We want to make sure to put it into the calculator correctly. That's your biggest thing. And that gets divided by 163,696. So we get approximately 239.7, so 0.8. Doesn't really matter, these won't be too. We can even round and just say this is 240. So from now on I'm just going to. So I've just gone through and divided all the populations by the land areas, and you can see, so out of the largest, or if we're looking for the largest population density, that would be New York, and the units are people per mile squared. Which solid of revolution is produced by rotating the shape below 360 degrees about the given axis? So we're talking about this axis here. This shape is being rotated around. Essentially be around a y-axis, and so that would look like this one. The approximate measurements of pyramid of Chichen Itza and the pyramid of Palenque in Chiapas, Mexico are below. What is the difference between the volume? Okay, volume, so we want to remember, so pyramid, we're going to use our volume formula. So our volume formula is 1/3, and it's big B, which is the area of the base, times the height. It's going to be the same thing for this. 1/3 big B area of the base times the height. So take our calculator, and I'm looking at, so this is going to equal 1/3 big B. So they give you big B. This is big B. This is area of the base. So they've done half the work for you. So it's just 1/3 times 1220 times the height, which is 98. They're both feet, and this is square feet, so I don't have to do anything else. 1/3. This one's 50, so this one's a lot smaller. Times 34. Just put it into the calculator. So 1220 times 98 divided by 3. Oop, that did not work. Divided by 3. So we have 39,853.33 repeating, and it doesn't say what to round to, so I'm just going to leave it. And then we have the temple of Palenque. So we're going to go 50 times 34 divided by 3, so 566.667, or 66 repeating. I guess I'll stay consistent. And they want to know the difference between these two volumes. So I'm just going to take my initial volume, so 39,853.33 repeating, and I'm going to, it's a little dark, I'm going to subtract the 566 minus 566, and we get 39,286.66 repeating. On the test, I believe that it's a, I think you round and then you choose an answer. Okay, when a chunk of metal is dropped into a container of water, the water level rises 2.1. Okay, this is water displacement. So water displacement is just going to be the amount of water. So that means the amount or the height, right? So water displacement, so we have 2.1 centimeters. The container is shaped like a square prism with a base that measures 3 centimeters on each side. So we can just draw this out really quickly. It's going to be a rough sketch. So this is my my square prism base that measures 3 on each side. So this is my base. I'm going to go 3 and 3. And what is the density of the metal if the mass is 43 grams? So I need to figure out what my height is, essentially, of my container, my square prism, and the height, what we care about, the height, is the water displacement, how much the water went up. So essentially we're going to be finding the volume of a 3 by 3 by 2.1 centimeter square prism. So I just have, so I'm going to do that over here. So volume of my square prism is going to be 3 times 3 times 2.1, and they're all in centimeters. So that's 3 times 3, you can't see that, 3 times 3 times 2.1, so 18.9 centimeters, and it's centimeters times centimeters times centimeters, so it's centimeters cubed. That's the volume, and so we want to know the density. So density, what is the density of the metal if the mass is 43 grams? So density equals mass over volume. So this is going to be equal to the mass is 43 grams over 18.9 centimeters cubed, and that's 43 divided by the answer we just got, and that's 2.3, we'll call it. So 2.3, and this is 2.3, I'm going to call it grams per centimeter cubed. Okay, Hayden works for Clar Spas. He's installing a circular spa that will be enclosed by a square deck. Alright, so we have a circular spa enclosed by a square deck. So very close. The radius of the spa, they mean like completely enclosed and touching all the sides. The radius of the spa is 4.25 feet. So this right here is 4.25 feet. What is the perimeter of the deck? This is a really easy question, so you just don't want to overthink it. If the radius is 4.25, then the diameter, right, then the other little piece is 4.25, which means that each side of this is 2 times 4.25. So, again, the radius is 4.25, and I guess I could have drawn it a little bit bigger. So, here we go. So, if it's 4.25 here, it's also 4.25 here, which means this is all, that's for half. That means this is also 4.25. So that equals 8.5. And so each side is 8.5, 8.5, 8.5. So we multiply 8.5 times 4, and you get 34. 34 feet. Okay. Suppose you are trying to decide what type of container in which you place your goldfish. You want one that will use the least amount of water. So the least amount of water means the smallest volume. Look at the diagrams below, they mean to the left, and determine which container will allow for the least amount of water to be used, assuming that the container must be filled to the top. So we just need to find the volumes for each of these. So this is 8 times 3 times 5, so 40 times 3 is 120 inches cubed. It's nice they also left them all in the same units. That really helps. This one we have a 7 times 2 times 10, so 7 times 2 is 14. 14 times 10 is 140 inches cubed. This one, so we have a cylinder, so our volume of a cylinder, remember the volumes of rectangular prisms are just length times width times height, but the volume of a cylinder is going to be the area of the bottom, so pi r squared times height. So we have pi r squared, so 9 squared times 7, so clear, 9 squared is 81, 81 times 7 is 567 times pi, So 1781, so way bigger than the other one. 1781. I'm just going to round. That's the volume, it's inches cubed. And then we have one more cylinder, same formula. So volume is going to equal pi r is 4 squared times 12, and that's 4 squared is 16, so 16 times 12 times pi. Now let's put in the calculator. So 16 times 12 times pi is 603. Call it 603 inches cubed. So the one that has the least amount of water is this one. Excuse me. Okay, Amber's square flower garden is half as wide as her square vegetable garden. What is the ratio of the area of the vegetable garden to the area of the flower garden? Okay, notice that it was flipped. So they gave you the relationship between the flower and then the the vegetable garden, and then they give you the ratio. They want you to find the ratio of the vegetable garden to the flower garden. So they're switching this up. So I think the best way to do this is just to draw a little picture. This is her square. I'm going to call it F for flower garden, and it's half as wide as her veg garden. And so I'm just going to plug in numbers because that makes it easier. So you can see, so if this was like her square flower garden is half as wide, so that'd make one side of this, let's say 2, and if this was 2 and it was half as wide, this one would be 4. And so what is the ratio of the areas? Well, if this is 2, then this would be 2, and this would be 4, this would be 4. Okay, so the area would be 2 times 2 is 4, 4 times 4 is 16. That's 16. So the ratio is 1 to 4, but that's for flower to veg, and they're looking for a veg to flower, so 4 to 1. Okay, next question. Imagine a cross-section defined by plane CBHE. Okay, so I've gone ahead and drawn in the plane CBHE. So CBHE, so it's a plane that actually cuts diagonally, and they don't tell you this, but this shape must be a rectangular prism, meaning this must be a right angle for you to be able to solve this. And so if we want it says determine the cross section defined by the plane, the dimension of the cross section or something times something. So that means that we need to find this distance and this distance. Okay, well, that distance is just given to us. This HE is just 5. So this is a 5. And then we need the long distance. And the question is, how do you find the long distance? Well, we can make a right triangle out of it. So if this is 10 in the back, then this must be 10 here because it's rectangular prism. And then we just have we have a right triangle which looks like this, and this is 16 and this is 10. That's a right angle, and we're looking for this distance here. So 16 squared plus 10 squared, take the square root of the answer, and you get 18.87, something along those lines. And so the dimensions are just as we just said. So I'm going to round this. I'm going to call this 19. But I think on your test it'll be a nice whole number. Like, it won't be a decimal, it'll be a whole number right away. Okay. A paper cup in the shape of a cone has a height of 10 units. I guess that's the big one. And a radius of 6 units. That's 6 there, and that's kind of light. And the water in the cup reaches a height of 7 units, so that must be the water right there. What is the value of R? So this is a question which would be very easy to overthink, but it's really, we're just making a comparison, and you can almost see it as 2 triangles that are similar. We know that they're similar because triangles are similar. These triangles are similar because they're right triangles. So I'm going to show you. So we have our outer triangle, our big triangle here, and that's a 6, and the height of this triangle is 10, because if it's 10 here, it's also 10 here. And then we have another triangle on the inside. It's a little smaller in here of the water, and that little triangle has a radius we don't know, but it has a height of 7. So we can just set up a proportion and figure out the radius of the surface of the water, which is r, and we can do this a bunch of ways. We'll go r is to 6, so small is to big as small is to big. So multiply both sides by 6, 6 cancels, you get r is equal to 42 over 10, which is 4.2. So 4.2 units. Okay. Tennis balls are often packed in cylindrical canisters. The diagram below shows that there are 4 balls in this canister. Okay, so important information, 4 balls in canister. Let C be the circumference of the canister. So the circumference of the canister, which would be the same as the circumference of a ball. Assuming each ball has a diameter of 6.54 centimeters and the balls fit snugly in the canister, which the following statements is true. So each ball, so you can't really see because it's covered by a label, but there are 4 balls in here, and each ball has a diameter of 6.5, we'll make that into a 4. 6.54, okay? So that's just one, and there are 4 of them, so the whole thing. So I need to know the height because it asked for the height of this canister. So the height is going to be equal to 4 times 6.54, which is, no, not 6 times, 6.54 times 4 balls. So 20, because it was the diameter, right? This is the diameter, that's important information. So the height of the whole thing is 26.16. So this whole thing here, 26.16. Okay, hard to read. Okay, so it's asking about, so what's the circumference of the canister? That's C. So that's easy. We can take the, so circumference is 2 pi r or d pi. And so we can take just the diameter they give us, the diameter of a ball. So is 6.54 and multiply it by pi, which would give us C. So 6.54 times pi. So that's 20.54, and it says centimeters. Oh, 546, so 55. Which doesn't really matter at all. And so we have to read through the statements, which is so we're comparing our C and our H. So our circumference is 20.55 and our height is 26.16. So C is less than H. Alright, so now we're on number 11. This looks a little different because I printed it out a little bit differently to give you guys more room. But the density of gold is 19.32 grams per centimeter cubed. So we have a density problem here. So we have D equals M over V. You have a solid gold cylinder with a base radius of 2 centimeters. So a gold cylinder, let's see, I'll draw it here. And it has a base radius, so radius equals 2 centimeters, and the height is 3 centimeters. This is a pretty big chunk of gold. Like, you're doing pretty well here if this is your gold cylinder. The gold weighs how many grams? So we know the density. We have density, check, and we can find the volume from the information given, and then we can solve for M. So it's going to be, we're going to multiply both sides by V, and we get V, D, volume density, is equal to mass. So first we need the volume though. So the volume of this is going to be the area of the base. So volume of a cylinder is going to equal, so the area of the base is pi r squared times the height, gives you the volume. So we have pi r is 2, so 2 squared is, I'll put 2 squared, times 3. So 2 squared is 4, so we have 12 pi. And I'm just going to multiply that. 12 pi. It's 37.7. So volume equals 37.7 centimeters cubed. You've got a lot of gold here. So, like I said, we're going to go volume, so 37.7 centimeters cubed times the density of gold is 19.32 grams per centimeter cubed. So you notice centimeters cubed cancels out, and you're left with grams, which is what you want. So we have 37.7. Essentially, I'm leaving my calculator and I'll multiply it by 19.32. Is 728 point, what does it say, round your answer to the nearest gram. Okay, so just 728. This is a lot of gold. Alright, a water trough. So this next problem is going to be lengthy. A water trough has 2 congruent isosceles trapezoids as ends and 2 congruent rectangles as sides. So this is going to be the trapezoid end, okay? And then it has rectangular, so then it has rectangular sides. So, and there are 2 of them. The exterior surface area of the trough is, so they're looking for the surface area. So you have to find the area of the trapezoid in the front, the trapezoid in the back, the rectangle on the right, the rectangle on the left, and then there's also a rectangle on the bottom. There's the base of this thing. So I'm going to first find the trapezoidal area. So if you remember the area, so area of a trap is going to equal to base 1 plus base 2 times h, and it's all over 2. So we have, and the problem with this problem is that we don't know the height. We don't know the height, okay, of our trapezoid, but we can find it. And we're going, actually I'm going to draw a bigger picture even. So this is the trapezoid at the end. So I have a, if you see the back, we know that the top of the trapezoid is 6 because it shows you it's 6 here. So this is 6, and the bottom, I should have made it much more slanted, is 1, okay? And this is 4. So I can find the height of the triangle because I know what this little piece is here. If this is, the whole thing is 6 and this piece is 1, then I know that this is 1. Let me just scratch this out. So I know this is 1, and then the 2 edges split would be, so they have to share 5 essentially. So it's 2.5 and 2.5. Okay. Sorry, my picture is not to scale. So we can find the height of my right triangle because we can do 2.5 squared plus b squared equals 4 squared. And so b squared is equal to, well, we can just find b, yep. So that would be 4 squared minus 2.5 squared. So 4 squared minus, let's see, 4 squared, sorry, trying to make it so we can see. 4 squared minus 2.5 squared. Then we take the square root. So it was 9.75 equals b squared. So we take the square root of our answer, and we get b is equal to 3.12. So the height is 3.12. So we can find the area of our trapezoid now. So this is b1, so I'm going to call this b1. b1 was 1 plus the whole thing in the top, the 2.5 plus the 1 plus the 2.5 again. Remember, this was 6 along the top of the trapezoid, so 1 plus 6 divided by 2 times the height. So the height of our trapezoid is 3.12, so that's 7. I'll do it out for you guys. So 1 plus 6, 7 divided by 2 is 3.5 times 3.12. Make sure that's what it was. Yep, 3.12. And oops, we have 34 point. Nope, I must have hit enter twice. I did. Let me just show that again. So it's 7 divided by 2 times 3.12 is 10.92. So 10.92 is the area of the face of that trapezoid. Okay. So we have the front, which is, I just said, 10.92. We have the back, which is 10.92. We have the rectangle on the side. So we know that the rectangle on the side, if this is 4 here, this is also 4, which makes this 4. So this rectangle is 32. The other rectangle is also 32. And then we have the bottom, which is a 1 by 8. So the bottom is 8. Alright, so we just add all that up. So the surface area of the trapezoid is going to be, like I just said, 10.92 on the front, 10.92 on the back trapezoid, plus 32 is the rectangle on the right, 32 is the rectangle on the left, and then we have the bottom, which is a 1 by 8, so 8. So you add that all together, and we get 93.84. And that's just the surface area of the trough here. So 93.84. I'm sure they're going to have you round on your test. We'll call it 93.8. How about that? So that's the surface area of your trough. Now they want the volume. The volume is really easy because you already have the area. So you have to think about the area of a trapezoid is if the trapezoid was sitting on its trapezoid. If the trapezoidal prism was sitting on its trapezoid, then you would find the area of the trapezoid, right? And it would be very easy to see. So this positioning is kind of like what they had in the Algebra Nation workbook when they went over the trapezoidal prism, but again, we take the area of the trapezoid and multiply it by the height, and if this was tipped up, you would be able to tell what I'm talking about. But it is a trapezoid, so it would look kind of like this. And so we have the area of that. We already found that, and that is your 10.92, and we multiply it by the height of this thing, which is 8 feet, and so that just is 10.98 times 8, so 87.44. 87.44. So sorry, 87.84. So we'll call it 87.8. Okay. Alright, and then it wants to know more. It says, if the trough is emptied until the water level is even with the mid-segment of the trapezoidal ends, there will be blank cubic feet of water left in the trough. So we have to find the volume again, but of half of the trapezoid. Yay! So, again, what they're saying here is that this water line has been reduced down to its mid-segment, right? And so now we're just looking at the water in the bottom half of this trough. Okay, so we need to find the area of our new trapezoid. Running out of room. So this is the bottom half. I'm just showing you this here. This is the bottom half. What is the mid-segment? Well, we know that we can find mid-segment, right? Before it went up a little higher, and it was 6, right? And 1 down here. So the mid-segment is 6 plus 1 is 7, so it's 3.5 is the length of the mid-segment. And then we know that we have the height of it. So let's see. We need to find the height of it is what we need to do. So just like we did before, we're going to do the exact same thing with like we did this. So except this time, instead of it being instead of our height being 3.12 that we solved, remember it's halfway. So now our height is, because this was 3.12, instead of it being 3.12, our height here, because it's halved, is going to be 3.12 divided by 2, so 1.56. So our height, h equals 1.56, and so the area of our trap is equal to, oh my gosh, no room, I'm going to say B1 is 3.5 plus B2 is 1 over 2 times 1.56. That's half the height of what it was before because it's been cut in half because it's a mid-segment. So 3.5 plus 1 divided by 2, we'll multiply that by 1.56. So 3.51 is the area of the trapezoid, the half trapezoid, the mid-segment trapezoid, so 3.51, and area we are looking at feet. Okay, and then we just want to know what the volume is. So I'm going to multiply, again, I'm talking about half, so I found this. I know the height because it's half the height of what I solved for before using the Pythagorean theorem. It was 1.56, so I know the distance here is 3.5 because I found that using the mid-segment theorem. This is 1 down at the bottom, so I am going to just take the area and multiply it by the height. So I have my new trapezoidal prism looks like this. So my area of my bottom is 3.51 and it goes up the same 8 feet, so 8. So I'm just going to take this and multiply it by 8, and my new volume is 28.08. Tough problem, but worth 3 points. So okay, you work in a packaging department of a company that makes soup. The old soup can is 8 inches high and has a diameter of 6 inches. Okay. Old soup can, O for old, is 8 inches high and has a diameter of 6 inches, which means the radius equals 3. Your department is asked you to design a bigger soup can that holds 1.5 times as much soup as the old can. Find the height of the bigger soup can if the diameter stays the same. So this is, again, so we want to know, it says what is the volume of the old can. So volume is going to be pi r squared times h. Sorry, let's write the formula. So volume of my old, that's a V, is pi 3 squared times 8, which is going to be equal to, well, it's 9 times 8, so 72 pi, so 3 squared times 8 times pi, so 226.19, 226 point, we'll call it, does not say how to round, 19. Okay, that's the volume, and it is inches cubed. And they want something that's, okay, so that's the old answer, 226.19 cubic inches, the height of the new can. So we know that if you want 1.5 times, your K is just 1.5. So we can just take our original height and multiply 1.5. So our new height is equal to 8 times K, which is 8 times 1.5, which equals 12 inches. 12 inches. You could also multiply the volume by 1.5 and then solve backwards. Okay, for the senior picnic, Miss Clark is using 2 cylinders to keep the food cool. The inside cylinder with a radius of 6 inches will be filled with potato salad. The inside cylinder with a radius of, okay, so there was a typo when I first released the review. Make sure that you have, it's 8 and 6 on the inside, and this says, again, inside on the 6, outside on the 8. The other one said the numbers didn't match, it had 10 in it. Anyway, so the cylinder will be placed inside a cylinder of radius 8 inches. The space between 2 cylinders will be filled with non-toxic, good, cooling solution. The amount of cooling solution needed to fill the empty space is blank cubic inches. So you want the volume of the big one, or the outer, minus volume of the inner. So volume of the outer is going to equal, again, volume of a cylinder is pi r squared h. So pi r of the outer is 8, so 8 squared times the height, which is 12, and the volume of the inner is equal to pi and then r squared times h again. So pi r of the inner is 6 squared times height is 12. So you can actually see that you can figure out, you can calculate what this is and what this is, or you can just realize that volume outer minus inner would equal to pi. And when they say you use 3.14, be really careful to use 3.14 and not pi. That'll make a difference. So pi, and then their heights are the same, so 12 times, and then 8 squared minus 6 squared. So this is pi times 12 times, this is 64 minus 36. Okay? Yep. So, you can also calculate the long way. So we have 64 minus 36, so 28. 28 times the height times pi. So the volume of the outer minus volume, oh goodness, I made a mistake. I used pi instead of 3.14. That's bad. 3.14 out of habit. So just kidding. So 28 times 12 times 3.14. I don't know why they did this on one problem. It's kind of annoying. So we have 1 round to the nearest tenth. Okay, 1055 cubic inches. And you can figure out what this is, and you figure out what this is, and you can subtract them and prove to yourself it's the same thing as if you just do it in one step. The manufacturer, let's try it again. A company that manufactures and ships canned vegetables is designing boxes in the shape of square prisms to meet specific requirements. So there was another typo on this question. My apologies. Square prisms, I had that there were 12 cans. You have to have 16 cans for it to be a square prism. Otherwise, you wouldn't be able to get cans to line up as a square prism unless you had a 4. We need one more line, a 4 by 4. So you have to have 16 cans, or obviously you could have 4 cans. You can have any, it just has to be even. You can have 9 cans, you have 16 cans, you have 25 cans, but it's got to be the same number of cans by the number of cans. Okay. So they tell you that the vegetables are packed into cans. They're 3.5 inches. So we have, I'll just do it a little bit bigger, but this would be like 1 row. And the cans are 3.5 inches in diameter and 3 inches high. So if they're 3.5 inches in diameter, say this is the side view, and then, so this is a side view of our box, and it says that company regulations state the boxes must be filled with 2 layers. So here are my 2 layers of 16 cans each. So again, this is a side view. This looks like this, and again, there are more cans here, and these are more like cylinders, not circles, but anyway, okay. The 3.5 in diameter, okay, so each one's 3.5 in diameter and 3 inches high. So this is 3, then this will be 3.2. What is the smallest amount of cardboard needed to meet the company's requirements? This is just a surface area question. And so if the diameter of 1 is 3.5, we need to know 3.5. That would be the diameter of 1, right? Of each one of these is 3.5. So it would be 3.5 times 4, so 14. So because it's 3.5, all the way across. So this is 14, and the height of this is 6. Okay. And if you're looking down on this, the top of this thing would be 3.5 times 4, which I already said is 14. 3.5 times 4, just in case you want to see. 14. So this is 14 by 14 on the top. Okay. So surface area is going to be 2 times 14. That's for the top and the bottom. And then on the sides, it's going to be plus 4 times 14. Because the face of this is, it was 3 inches high. There are 2 of them. That's 6. 6 times 14. So you have the front. Oh, sorry. Times 6. It's a time sign. So you have the front and the back. That's 2. And then you have the left and the right, which is the same, 14 by 6. So it's 4 times 14 by 6. So 2 times 14 is 28. And then this is 14 by, let's see, oh, I made a mistake. I didn't multiply it by, oh yeah, by 14. Okay, getting messy here. So again, the area of the top and the area of the bottom. So the area of the top is a 14 by 14. So the area of the top, oops, gosh, just dropped a 14 out of there. So 14 times 14 is 196. So the top is 196. The bottom is 196. So that's 2 times 196. That says 14 times 14 right there. Can't read that, but it does. Okay. So, and then we add that to 4 times 14 times 6. Didn't like that. 14 times 6 times 6. There you go. 84. So 84. So times 4. So 336 plus. So 2 times 196 is 392 plus 4 times 84 was 336. So we add the 2 together, and it's 728. Gotta visualize those cans. Okay, 3 to go. A giant scoop operated by a crane is in the shape of a hemisphere, and the radius is 42. So a hemisphere is half of a sphere. So the scoop is filled with molten steel. The steel is then poured into a cylindrical storage tank with a diameter. Okay, so we're going from a hemisphere to a cylindrical storage tank. The radius of the hemisphere, R, is equal to 42. Okay, so the volume of a hemisphere is 4/3, and then it's pi r cubed, but it's divided by 2. So the formula is really 2 over 3 pi r cubed, and the formula for this volume is pi r squared times height. Okay, so we want to know And the diameter of this is 60, so the radius, I should have written it there, radius is equal to radius is equal to 30 inches. So we're looking for what is the height. That's what we don't know of our cylinder. So the volume of our hemisphere is equal to 2 over 3. Again, 2/3 came from 4/3 being divided by 2 because it's a hemisphere, not a full sphere. Pi, radius is 42 cubed. Here we go. Put it here. So we have 42 cubed times pi times 2. We divide that by 3. So big number, 155,169.54. You could also leave this in pi, which is probably a lot neater of a way of doing it actually. So 42 cubed times 2 divided by 3 is 49,392 pi. That's the volume of the hemisphere. I'm going to leave it in pi because you have to have pi again here, and you might as well just keep it in pi. Okay, the volume here, so volume is pi, the radius is 30 squared h. So I'm just setting this up. So this is going to be equal to, we don't know yet, but we know that the volume is going to be the same, right? So if you know the volume of the hemisphere is the same as the volume that you're going to have when you're in your cylinder, then you can set them equal to each other. So again, volume of hemi is equal to the volume of the cylinder, because you're putting the same volume into the cylinder. They want to know how high it fills up. So volume is going to be 49392 pi, and that's equal to pi 30 squared, because the radius of your cylinder is 30 squared. So you have 900 times h. And your pi's cancel out, and you divide both sides by 900. That's why you keep it in pi, because it makes it really pretty. And you get 49,394 divided by 900, which is, your height is equal to 54.88. You can decide. It doesn't tell us what to round to, but we'll say 54.9. Okay. Which of the following describes what will occur to the volume of a sphere if the radius were doubled in length? Okay, we know that, so the radius is doubled, so we're talking about a sphere, right, in a bigger sphere. The radius here is whatever, it doesn't matter. We'll say it's 1, and the radius here is doubled in length, so radius equals 2. So we know that our k, in other words, our k is equal to 2, and the relationship of the volume is when you compare two volumes, you take k and you cube it. If it was areas, you take k and you square it, and if it's just radius, it's just single dimension. So 2 cubed is going to equal 8. So it's 8 times as big as it was before. Sorry, pause for coughing. Okay, at a local pet store, Robbie bought an aquarium shaped like a truncated prism. Truncated means it was cut off. A truncated prism can be made by slicing a prism with a plane perpendicular to the base of the prism and removing the resulting triangular prism as shown on the diagram. The area of the base of the aquarium is blank, and the capacity in cubic inches is blank. And so they want the area of the base, and then the area, they want the volume of this. This question is weird, and the way it's drawn out is funny, so I'm going to... Okay, I tried making this better, but I don't think I did, because the picture is terrible. But the bottom of this, so truncated means that it was a rectangle, and then this corner that I have in pink was cut off. So the only way to solve this problem, first of all, is for this to be a rectangular prism. And so here we go, the area of the base of the aquarium. So what we're going to do is find the area of the base as it is a rectangle, and then subtract the area of the triangle. It also means that this must be a right angle. And once you see that these are right angles, then everything's fine. So the area of the base, area of the rectangular base before it was cut off would be just, so you got to figure out what this is. So if this is, it says here it's 20, so if it's 22 up here, it's 22 down here. And if it's 34 up here, it's 34 down here. So this is the area of the base. If it was the whole thing, would be 22 by 34. And 22 times 34 is 748 inches squared. Now we need to find the area of the pink triangle. So area of triangle. And that's going to be, so we have our triangle here. Again, we're saying this is a right angle. So what is this triangle? Well, the triangle, and it doesn't go actually as far as that little pink line. So the triangle is just from here to here. Okay, and it's a right triangle. So if this is 5 and this whole thing was 34, then this piece right here, this piece of our triangle, is going to be 34 minus 5, which is 29. And this side, if it was 22 before, because it's 22 here, it would be 22 here, 22 minus 5, so it's going to be 17, which makes this piece here, it doesn't really matter, because the area of the triangle is 1/2 base times height. So we're just 1/2 base, which is 29, times height is 17, so 29 times 17 divided by 2 is 246.5. So the area of the triangle is 246.5. So the area of the base of this thing is 748 minus 246.5. Okay, so 748, that was the whole rectangle, 22 by 34. 748 minus 246.5. So 501.5. Okay. That's here. Okay. And now you want to know the volume. So that at this point is pretty easy. So you just take the area of the triangle and you just go up. So it's 501.5. That's so this is our prism. So it's going to be volume of the prism, this weird truncated prism, is just going to be the area of the base times the height, and the area of the base is 501.5 times the height is 23. So 11,534.5 volume of aquarium. Okay, that's it. So first half of the review is really easy. Second half, not so easy. This was inches cubed. Let me know if you have any questions.